The following video is part 2 of the video on logarithmic differentiation. We just learned how to do logarithmic differentiation to find the derivative of a to the x. Now let's use it to find the derivative of arc sine of x. We will use the equation that sine of arc sine of x equals x. This is because sine and arc sine are inverse functions of one another. Just like before, we will take the derivative of both sides of this equation. The derivative of sine of arc sine of x uses the chain rule, so we'll take the derivative of the outside, leave the inside the same, giving us cosine of arc sine of x, times the derivative of the inside function, which is d by dx of arc sine of x, since we don't know what the derivative of arc sine is. The derivative of the right side is going to be 1. Now we just solve for d by dx of arc sine of x. Unfortunately, we're left with 1 over cosine of arc sine of x, which in practical terms would be very hard to compute. So what is cosine of arc sine of x? In order to figure this out, we'll use the Pythagorean theorem, which says that sine squared theta plus cosine squared theta equals 1. We can solve for cosine theta by first moving the sine squared theta to the other side, and then taking the square root of both sides. We end up with cosine theta equals the square root of 1 minus sine squared theta. If we let theta equal arc sine of x, we notice that cosine of arc sine of x is equal to the square root of 1 minus sine squared arc sine of x. Plugging this back into our derivative, we're left with 1 over the square root of 1 minus sine squared of arc sine of x. And thankfully, sine of arc sine of x is x, so we're left with 1 over the square root of 1 minus x squared. This is the derivative of arc sine of x. Let's try another one. Let's do arctan of x. We'll use the identity that tangent of arctan of x equals x. We'll take the derivative of both sides of the equation. The derivative of the outside function will be secant squared. We leave the inside the same, so arctan of x, times the derivative of the inside function, which we will just leave as d by dx of arctan of x. The derivative of the right-hand side is just 1. So we're left with d by dx of arctan of x equals 1 over secant squared of arctan of x. Once again, computing 1 over secant squared of arctan of x is annoying, so we would like a shortcut to simplify this. What is secant squared of arctan of x? For this, we'll use the identity 1 plus tangent squared theta equals secant squared theta. And we'll let theta equal arctan of x. If we do this, we get 1 over 1 plus tangent squared of arctan of x. I just replaced secant squared with 1 plus tangent squared, and I replaced theta with arctan of x. Thankfully, tangent of arctangent of x is just x, so I'm left with 1 over 1 plus x squared. This is the derivative of arctan of x. We'll try one more of these. Let's find the derivative of x to the x. For this, we'll use the natural log of x to the x equals x times the natural log of x. Remember, with natural logs, we have the ability to pull the exponent out front. We'll take the derivative of both sides of the equation. The derivative of natural log of x to the x will be 1 over x to the x, that's the derivative of the outside, leaving the inside the same, times the derivative of the inside, which is d by dx of x to the x. For the right-hand side, we'll use the product rule. The derivative of the first thing, x, leaving the second thing alone, ln of x, plus, leave the first thing alone, x, times the derivative of the second thing, 1 over x. Now we get d by dx of x to the x by itself, and we end up with x to the x times ln of x plus 1. Notice that x times 1 over x simplified to 1. Thus we're left with x to the x times ln of x plus x to the x. And this is the derivative of x to the x.